honor for us to be accepted as participant in this conference. Here, I'm as a representative of my team who will present the result of our research about particle swarm optimization for solving the high routing problem with time units in the food chain industry. This is the outline of the presentation that I will deliver today. I will talk mainly about the result introduction, then the methodology, the third one is the result analyze, and the last one is the conclusion. Before we start talking about our study case, I will briefly explain the background of this research. The 2020 pandemic was caused by a new coronavirus called SARS-CoV-2, and the virus has characteristic highly transmissible. That's why this coronavirus has spread really fast all over the world and known as coronavirus disease 2019, or we can call it COVID-19. Governments from around the world are trying to respond and stop the spread of this virus by making various policies. One of them is the Indonesian government, which make the regulation on social activities, and the policy made to regulate economic and social activities to reduce the time and number of people in one area. The implementation of this regulation has a major impact on the decline in the economic activity and behavior of the community. Because this regulation, there are so many industries that will be affected, and one of them is the food industry. The regulation on social activities have resulted in changes in people behavior. People during this pandemic tend to do a lot of activities at home, including cooking activities. Because of that, total demand in the food industry, especially restaurant, decreased compared before the pandemic. Many companies eventually went bankrupt due to their inability to cover the high operational costs. Based on Indonesian statistical data, the number of food industry in 2020 decreased by 1.58% compared to the previous year that always increased. The decline in the number of food industry cannot be separated from the existence of good company management in dealing with uncertain situation. Moreover, to be able to survive and considering the competition, company needs an appropriate the business strategy. The implement business strategies will be able to maximize the profit by minimizing the expense costs. Okay, the next one is the case study. The case study in this research is a problem in XYZ company, where this company is one of the food restaurant chain in Bali, Indonesia. In fulfilling each outlet demand, XYZ has one central kitchen, or we can call it CK, that used to store raw material from supplier and will be distributed to each outlet. The problem that XYZ have is innovation in the current distribution method that contribute to the high distribution cost that the company should spend. Because of that, we propose a new distribution method in this company. So this is the illustrated that the current distribution system and the new distribution system plan. In here, we can see the current distribution system has a high distribution cost because each day and every outlet send one employee to pick the product from CK. Every day, each outlet can make 2 until 10 trips to CK, or we can know it as operator pickup. While in the new distribution system, delivery of product of each outlet is carried out by the CK, where the company will buy a vehicle for distribution. This type distribution system, we can know it as a direct delivery. In here, the new distribution system has goal to minimize the distribution cost, which will be influenced by operational vehicle efficiency. And the operational vehicle efficiency, it can be done by determining the most appropriate distribution route to minimize transportation costs that expensive. For finding the optimum route determination strategy for company problem, VRP is the most appropriate model for use this problem. The VRP model has several variations, which are grouped based on the limitation they have. The most appropriate model for the company where depot and outlet have their service time in delivery and reserving was the vehicle routing problem with time windows, or we can call it VRPTW. Theoretically, VRPTW is combinatorial problem that belongs to NP-hard problem. So one method that can be used to solve the NP-hard problem by using meta-heuristic method. And one of the meta-heuristic method that the researchers recently use is particle swarm optimization. The simplicity of the PSO algorithm by producing good performance makes PSO used by researchers in various optimizing problems. Besides that, the ease of encoding and decoding and the fast convergence to the optimal make the algorithm often applied. So this is some of previous research that talk about VRPTW and PSO algorithm. The next slide is talking about the methodology. In this research, we use mathematical model of VRPTW that developed by Kalahuge in 2001. And this model is to minimize the total transportation cost by limiting time window at each customer. So the objective of this research is to minimize the travel cost by vehicle to serving the customer. And the next one is to find the solution of with PSO algorithm begins by randomly initiating each particle to get the initial P base and G base. And after that, each particle will be updated in velocity and location to get the best objective value. And this is a pseudocode for our research. And the third section is a result analysis. The first one is the data that we use in this research. They are the demand data, distance data, until the vehicle specific data that we use for the new distribution method. In here, for the time data, we can see that there is a time limit for the outlet and depot service time. And for unloading time, we estimate is 10 minutes. The next one is the data processing. Data set used in this research were divided into small instant and large instant data. The small instant data show that data for one-time delivery, while the large instant data show delivery scenario data in a day. The large instant data was categorized into two scenarios. First scenario using two-wheel motor vehicle and a delivery box of 50 kilogram capacity. And the second scenario using a three-wheel motor vehicle with a maximum capacity 250 kilogram. And the first step of this research is a model verification and validation. The process of model verification and validation is carried out by using the small instant data type. First one is the model verification. In this picture, it can be seen that there are no inappropriate routes or double routes. So it can be said that the mathematical model used is to represent the existing problem. And the second one is the model validation that done by looking at the vehicle capacity limit, service time, and the objective value where nothing has been filled and it has some output value as the manual calculation. And the next one is the parameter tuning. Parameter tuning was conducted to discover the parameter combination that generates the best solution quality with short computational time. In this research, parameter value was determined before the algorithm was running, so called offline tuning. And the parameter tuning method was the one factor at a time or OFAT, where one parameter will be tested for each value and assuming that the other untested parameter have fixed value. Parameter value determined for this meta heuristic was adopted from a literature review of previous research. In the PSO algorithm, there are 4 parameters tested, namely the number of iteration, inertia weight, number of particles, cognitive factor, and social factor. In the number of iteration, it can be seen that the best solution is obtained by the parameter value of 500, and the best inertia value is obtained by 1. In the graph number 3, the number of particle or swarm size, there is a trade-off between the quality of the solution and the length of computational time. So then the parameter value is 40 is the best one. And the value of cognitive factor and social factor with a value of 2. And after getting the combination of parameters that can produce the best solution, the next step is computational research for small instances. Based on the table, it can be known that using the exact method with MPL software for small instance can produce an optimal value of 4,240. And the result of meta-heuristic method using Visual Studio software can produce the same value as the exact method of 4,242. And for the computational time of the two methods, it can be seen that the exact method produces an optimal solution with a short CPU time compared to the CPU time generated by the meta-heuristic method. However, this difference is considered not much different. Moreover, it can be concluded that the PSO algorithm can produce an optimal solution with short computational time for small data instances. Using the same base combination of parameter, here is the computational result for the large instances. First, for the first scenario using 50 kilogram. And based on the table, it can be seen that the computational result for large data instance, it can be concluded that with a short CPU time, the meta-heuristic method can produce a very good fairly good objective value compared to the exact method, which does not produce a solution after limiting the CPU time to 7,200 seconds. So the meta-heuristic method with the PSO algorithm can produce the best objective value in each instances. And for the large instance, in the second scenario is the same where the exact method does not produce solution root for all instances, where the PSO algorithm produce solution for all instances with short computational time. This proves that for larger and more complex data for the food chain industry case study, the PSO algorithm can obtain a fairly optimal objective value with a very fast computational time. It can be said that PSO algorithm can be applied to case in Bali, Indonesia, and can be implemented in the company operation. After knowing the performance of the PSO algorithm used, it's known that PSO algorithm produce good objective value with a faster computational time than the exact method. So the next data is the root generated from the application of the PSO algorithm for root determination of at XYZ company for two scenarios that we made. And the last one is after getting the total cost for each delivery and the route of vehicle to be taken, the next step is to compare the total cost generated by the proposed route with the total transportation cost that the company currently has. It can be seen that the total cost of the new distribution system has a lower cost compared to the total cost currently owned by the company. So it can be said that optimizing the route determination using meta-heuristic algorithm can minimize the transportation cost owned by the company. And the last content of my presentation are conclusion. So based on my result, we can conclude first, the result obtained at the particle swarm optimization can produce a solution that is close to optimal with a fast computation time in the case of determining the route of the food chain industry. And the second one is the company can use the result of the PS algorithm as a route determination in their operation. By implementing a new distribution system, the company could save distribution costs by up to 50%. And for the future user can apply this proposed algorithm with different modification or input parameter to get a better solution. The future research might use developing PSO algorithms such as a hybrid PSO and GLM PSO to get a good performance in solution quality. On the other hand, for the future research might use another meta-heuristic algorithm to test the best performance to solve VRPTW problem. Okay, so that is for me.
Thank you, Professor Islami, for your quick and nice presentation.